Remember that your go-to is going to be to use this table that's on the top of page 2. This will be what you use to help you throughout the whole packet. Please also think about, you could tear your packet in half so that it's easier to view the table when you do the homework, or you can even take a picture of the table to help you as well. Okay, so before we get started, I told you guys to not worry about where it says function notation description. So I'm going to have us cross that out, and then I'm going to have you add the transformed equation for number 2. The transformed equation is g of x equals the square root of negative x, and the negative is on the inside of the square root. So all you had to do is add this for number 2. The first thing that I'm going to do for number 1 is I'm going to look at what the original equation was and how it changed. So our original equation is the square root of x. The square root of x, if we always just use that and we use our points as 0, 1, 4, and 9, I'm always going to use those because those are nice points in terms of we can take the square root of them. So then the square root of 0, the square root of 1, the square root of 4, the square root of 9, all of those are nice clean numbers. So we have 0, 1, 2, and 3. So if I think of my original equation at 0, 0, that's the first point. 1, 1 is the next point. 4, 2 would be the next point. And then 9, 3 would be the next point. So if I look at the equation that's drawn versus the equation that I see, the only change that happened was that it shifted 1 to the left. So we have a translation of left 1. If you were to use your table, it would have said a horizontal translation of left 1. You don't need to write horizontal. We know that if you go to the left or to the right, that's horizontal. So the only other thing that we want to do is then write what the transformed equation would be. And if you use your table, you'll see that if it's a left translation, we put how far it went left inside the square root. So I'm going to have the plus 1 inside the square root. And because it's the transformed equation, we're going to write it as g of x. Okay, for number 2, this one says that the original equation is square root of x. So it's the same as what we did in purple right here. We will always have the original equation as what I just did in purple. It says the transformed equation is g of x equals the square root of negative x. If you look at your table and you look for the place where there's a negative inside the square root, you'll see that that's a reflection, and it'll be across the y-axis. So what I can do is I can draw what my original is. Remember, it's always going to be at 0, 0, 1, 1, 4, 2, 9, 3. And then I can be like, okay, if that is our original, that's F, then I'm going to put what G is. And so G would just be flipped across the y-axis. So it's still going to start at that same place, but it would then be right here. And then it would be at negative 4, 2, and so on. So this one is G. You do not have to write the F1. You just need to have what I'm going to highlight right here. So you only need to have the highlighted part. You don't need to include the F part. Questions on that one? Okay, so this is honestly just helping you guys get through your homework even, so getting it done early. Looking at the next section, problems 3 through 8, you're just going to describe the transformation of F that results in G. So you're going to look at how it changed. So if we look at number 3, this one has a subtraction on the outside of the square root. So if we look at our table and we look for where we have it on the outside being subtracted, that is a translation down that much. So we're going to have a translation down that much for number 3. So it's going to be a translation, down 9. If you have a subtraction inside the square root, we're going to see that it is a translation to the right. So if we look at our table, we'll see that it's just a translation to the right that much. So we're just going to write translation to the right 7. I'm going to do just a few more. Let's go ahead and do number 5 and number 8 as well. So if you have a 4 on the inside of the square root, so it's being multiplied, the x is being multiplied inside the square root, that is just like this one. Now, if you're careful, you'll see that it says it's a compression, a horizontal compression by a factor of, and this would be 1/3. So we want to write it as 1 over what the number is. So we're going to write that as a horizontal compression by a factor of, and instead of just putting it as 4, it's going to be 1/4. And that's because that 4 is inside the square root. So that's why it's written that way. If we have it on the outside, though, like number 8, this one, we just keep it exactly as it is. So if it's on the outside of the square root, like this one, it's just a vertical compression by a factor of exactly that. The number won't change. So for number 8, we just say a vertical compression by a factor of 2/3. We don't have to change the number at all. Okay, I'm going to do a few other ones from the next section. So if we look at problem 9, this one gives it to us in the description form. So we want to look for where we have 5 in front of the function. So if we look at our table, we want to find where 5 is in front of the function. So just like right here, 5 is in front of the function. So we would rewrite that as g of x equals 5 root x. And it's a stretch by that factor. Whoops. So I would write g of x equals 5, and then I would write our original function, which is the square root of x. So you want to make sure the 5 is in front of the square root. And when we look at this and we look at what it's describing, the change, it's a vertical stretch by a factor of 5. Whereas in number 10, we have the value inside the function, so it's inside the parentheses. So when we look at that one, I want to make sure to go to the one that's inside the parentheses. So like this. So we're going to write it just like that, inside the square root. So this will be g of x equals the square root of 8x. And this one is similar to number 5, where it's a horizontal compression by a factor of, and you're going to put it 1 over that number, so 1 over 8. Okay, we'll do a few more, and then you guys will have the rest of the time in class. So let's go ahead and jump to number 12 on the next page. So number 12 on page 6. For this one, we first want to write or to observe what the original change is. So if we look at this, it went from just the original F here to being stretched upward. And if we look by how much, it started at 1, but then it went all the way up to 3. It started right here at a value of 2, but then it went all the way up to a value of 6. So when we think about that, that is a vertical stretch by a factor of 3 because it went multiplied by 3. You do not need to worry about the function notation description. The only other thing I want us to do is worry about our equation. And if we look for where the equation, where we have it stretched by a factor of 3, it's going to be where we have the number on the outside or in front of the square root. And it's going to then be 3 root x. Okay. For problems 14 through 16, you can also get rid of the function notation description. These ones tell you how to change it, and you're just going to write what the equation would be, and then you're going to draw it. So, for number 14, we have translated left 2. So, the equation, if we look at our table, if it's translated to the left, we're going to see that translation as plus that amount inside the square root. So inside the square root, it's going to be x plus however we're moving to the left. So that would be plus 2. All right, now, when you actually draw your graph, you can draw, I always like to draw the original one just so that I have something to go off of, and then I know that the new one just gets scooted a little bit. So if this one is moving to the left 2, it's going to scoot, just every point will just scoot to the left 2. So this will go to the left 2. This one will go to the left 2. Make it that simple. Okay. For number 15, I'm going to have you guys, you can cross off number 15 on page 6. I still want you to do number 16 though. Also, on page 7, you can cross off number 2. And you also do not have to do the function notation description for that part. And lastly, I'm going to have you cross off a few things on page 8. For page 8, you can cross off the function notation description. Also along the bottom, you can cross it off. And you're going to be able to cross off number 16. Okay.